scrubber systems are a diverse group of air pollution control devices that can be used to remove some particulates and/or gases from industrial exhaust streams. The first air scrubber was designed to remove carbon dioxide from the air of an early submarine, the Ictineo I, a role which they continue to be used for to this day. Traditionally, the term scrubber has referred to pollution control devices that use liquid to wash unwanted pollutants from a gas stream. Recently, the term is also used to describe systems that inject a dry reagent or slurry into a dirty exhaust stream to wash out acid gases. Scrubbers are one of the primary devices that control gaseous emissions, especially acid gases. Scrubbers can also be used for heat recovery from hot gases by flue-gas condensation. There are several methods to remove toxic or corrosive compounds from exhaust gas and neutralize it. Combustion. Combustion is sometimes the cause for harmful exhaust gas, but, in many cases, combustion may also be used for exhaust gas cleaning if the temperature is high enough and enough oxygen is available. Wet scrubbing. The exhaust gases of combustion may contain substances considered harmful to the environment, and the scrubber may remove or neutralize those. A wet scrubber is used to clean air, fuel gas or other gases of various pollutants and dust particles. Wet scrubbing works via the contact of target compounds or particulate matter with the scrubbing solution. Solutions may simply be water or solutions of reagents that specifically target certain compounds. Process exhaust gas can also contain water-soluble toxic and/or corrosive gases like hydrochloric acid or ammonia. These can be removed very well by a wet scrubber. Removal efficiency of pollutants is improved by increasing residence time in the scrubber or by the increase of surface area of the scrubber solution by the use of a spray nozzle, packed towers or an aspirator. Wet scrubbers may increase the proportion of water in the gas, resulting in a visible stack plume, if the gas is sent to a stack. Dry scrubbing. A dry or semi-dry scrubbing system, unlike the wet scrubber, does not saturate the flue gas stream that is being treated with moisture. In some cases no moisture is added, while in others only the amount of moisture that can be evaporated in the flue gas without condensing is added. Therefore, dry scrubbers generally do not have a stack steam plume or wastewater handling disposal requirements. Dry scrubbing systems are used to remove acid gases primarily from combustion sources. There are a number of dry-type scrubbing system designs. However, all consist of two main sections or devices: a device to introduce the acid gas sorbent material into the gas stream and a particulate matter control device to remove reaction products, excess sorbent material as well as any particulate matter already in the flue gas. Dry scrubbing systems can be categorized as dry sorbent injectors or as spray dryer absorbers. Spray dryer absorbers are also called semi-dry scrubbers or spray dryers. Dry scrubbing systems are often used for the removal of odorous and corrosive gases from wastewater treatment plant operations. The medium used is typically an activated alumina compound impregnated with materials to handle specific gases such as hydrogen sulfide. Media used can be mixed together to offer a wide range of removal for other odorous compounds such as methyl mercaptans, aldehydes, volatile organic compounds, dimethyl sulfide, and dimethyl disulfide. Dry sorbent injection involves the addition of an alkaline material into the gas stream to react with the acid gases. The sorbent can be injected directly into several different locations: the combustion process, the flue gas duct, or an open reaction chamber. The acid gases react with the alkaline sorbents to form solid salts which are removed in the particulate control device. These simple systems can achieve only limited acid gas removal efficiencies. Higher collection efficiencies can be achieved by increasing the flue gas humidity. These devices have been used on medical waste incinerators and a few municipal waste combustors. In spray dryer absorbers, the flue gases are introduced into an absorbing tower where the gases are contacted with a finely atomized alkaline slurry. Acid gases are absorbed by the slurry mixture and react to form solid salts which are removed by the particulate control device. The heat of the flue gas is used to evaporate all the water droplets, leaving an unsaturated flue gas to exit the absorber tower. Spray dryers are capable of achieving high acid gas removal efficiencies. These devices have been used on industrial and utility boilers and municipal waste incinerators. Absorber. Many chemicals can be removed from exhaust gas also by using absorber material. The flue gas is passed through a cartridge which is filled with one or several absorber materials and has been adapted to the chemical properties of the components to be removed. This type of scrubber is sometimes also called dry scrubber. The absorber material has to be replaced after its surface is saturated. Mercury removal. Mercury is a highly toxic element commonly found in coal and municipal waste. Wet scrubbers are only effective for removal of soluble mercury species, such as oxidized mercury, Hg2+. Mercury vapor in its elemental form, HgO, is insoluble in the scrubber slurry and not removed. Therefore, additional process of HgO conversion is required to complete mercury capture. Usually addition of the halogens to the flue gas are used for this purpose. The type of coal burned as well as the presence of a selective catalytic reduction unit both affect the ratio of elemental to oxidized mercury in the flue gas and thus the degree to which the mercury is removed. Wet scrubbers can be used for heat recovery from hot gases by flue gas condensation. In this mode, termed a condensing scrubber, water from the scrubber drain is circulated through a cooler to the nozzles at the top of the scrubber. The hot gas enters the scrubber at the bottom. If the gas temperature is above the water dew point, it is initially cooled by evaporation of water drops. Further cooling causes water vapors to condense, adding to the amount of circulating water. The condensation of water releases significant amounts of low-temperature heat per ton of water that can be recovered by the cooler for example district heating purposes. Excess condensed water must continuously be removed from the circulating water. The gas leaves the scrubber at its dew point, so even though significant amounts of water may have been removed from the cooled gas, it is likely to leave a visible stack plume of water vapor. Scrubber waste products. One side effect of scrubbing is that the process only moves the unwanted substance from the exhaust gases into a liquid solution, solid paste or powder form. This must be disposed of safely, if it cannot be reused. For example, mercury removal results in a waste product that either needs further processing to extract the raw mercury, or must be buried in a special hazardous wastes landfill that prevents the mercury from seeping out into the environment. As an example of reuse, limestone-based scrubbers in coal-fired power plants can produce a synthetic gypsum of sufficient quality that can be used to manufacture drywall and other industrial products. Bacteria spread. Poorly maintained scrubbers have the potential to spread disease-causing bacteria. The problem is a result of inadequate cleaning. For example, the cause of a 2005 outbreak of Legionnaires disease in Norway was just a few infected scrubbers. The outbreak caused 10 deaths and more than 50 cases of infection. See also, wet scrubber, baffle spray scrubber, ejector venturi scrubber, liquid to gas ratio, mechanically aided scrubber, spray tower, spray nozzle, stripping, venturi scrubber. Flue gas desulfurization, flue gas condensation, mercury cycle, oil desulfurization, electrostatic precipitator. BS 4994 Chemical Process Plant Equipments in FRP, references